All right, guys, so that's what you should be getting in that table, right? And I sorted mine. You don't have to sort it, but it just makes it easier if you sort it. Should be cool with that? And like I said, this is not symmetric. So, but if you check list 2, does it add up to be 0? Of course it does. That's what the mean does. The mean sits in the middle of the values. Not in the middle position-wise, but in the middle value-wise. You'll always have equal amounts negative as positive. It'll always add to 0. That sucks. That's why we square it. Now, just to show you, this problem wasn't that bad. You could just plug all those values in and add them up. But here's a shortcut of how to add a list up. Okay. First off, you quit. Get out of here. Quit. If I go to, see above where it says stats? See how it says list? And I want to do something to my list, so that kind of makes sense. I want to add up L3, don't I? So the next thing I want to do. So if I go second stat, sorry. Go to math, I want to sum. I want to add up. I want to add up L3. Bam. Okay. And you get 54. That's what you guys got. So this wasn't like a huge list of data, but if I give you a larger list of data, shit, yeah, I want to do that. Okay, okay. So everybody should have gotten 54 down here. Over here, you should have gotten 0. You always will get 0, or close to it if you had to round. We didn't have to round here. All right. So up here, this is where people make the biggest mistakes is, and I don't blame you really. Algebra sort of sets you up for this, and it's not algebra's fault. It's got its own shit to worry about. You don't plug stuff in here. This whole thing is 54. That's why I try to get you guys to write the symbol for what the hell it is that you just did. Don't just put a 54. Tell yourself what it is. Wherever you see that, you replace it with what it is. And what's n minus 1? 8. So s squared is 6.75. 6.75, I like it. That is the variance. Now, right now, the variance doesn't mean a damn thing. It's like a middleman. It's like we're not done with the problem. Later in the semester, we'll talk about what the variance by itself means. Right? So to get the standard deviation, I square root that. To undo that square stuff I had to do. So what's the square root at 6.75?
2.5981.
2.59.
Yeah, 2.598 is fine. If you put 2.5981, that's beautiful. I said at least 3 places. Dear God, don't give me like 10 places or some shit. If you give me 2.6, you will lose points. Yes! I'm a math teacher. We're all evil, so you shouldn't use that shit. But also because 3 decimal places is what kind of maintains, kind of minimizes error propagation. And I don't want you guys to have to worry about how to keep the whole damn value in there. It's just too much. Okay, now, let me ask you this. Are you ready? All right, start simple. We'll start simple. Guys, look at me. This has nothing to do with this yet. I want to explain the idea behind part C. If my mean was 10 and my standard deviation is 2, how far away from the mean, how many standard deviations away is 12? It's one step. I call it a step. Now, please don't write step on your test when I ask you a question. Write standard deviation. But the reason I call it a step is if my data is 10 and the standard deviation is 2, like 2 feet, then if I step 2 feet, I kind of can see my data. I can see it. I can walk around in it. Hey, data. How you doing? Now, if my mean was 10 and my standard deviation was 0.1, stay with me now. If my mean is 10 and my standard deviation is 0.1, is 12 really far away? Yeah, holy shit. So this is an attempt to figure out, relative to all the data, how far away is something. This is the way we measure distance, right? So if my mean is 10 and my standard deviation is 0.1, I call that a step. I want to step by 0.1, or else I'm going to miss the whole. If I step by 2, I've missed everything. I don't see shit. So that's why I call standard deviation steps. To be really honest, standard deviation is sort of like setting the tick marks on a ruler. You with me? Or choosing your units. So if I'm talking about how far apart two people are, you could maybe use inches or feet. If I'm talking about how far apart two cities are, do you want to use inches? Not even feet. You want to use miles, maybe, right? Especially because we live in the only place that doesn't use metric. But oh well. Okay, so the standard deviation sort of sets up what your units of measurement are. And then when I lay that ruler down to see how far apart two data points are, that's how I measure distance. I look at the tick marks. So if my mean is 10 and my standard deviation is 2, 12 is 1 step away. How far away is 11? My mean is 10.
Half.
My step size is 2. 11 is half a step away. Right? So how are we doing that? Well, if I'm interested in, let me do it right here so I'm not turning that thing all over the place. If my mean is 10, I want to get to 11. Right? I want to know how far do I have to go. I just have to go 1. And every step I take is 2. So I just need half a step. So physically, if I see how far apart two things are and divide by how big each step is, it tells me how many steps it's going to take. Does that make sense? If I have to go 5 feet and every step I take is 2, how many steps do I have to take? 5 divided by 2 is 2.5. I got to take 2.5. Yes?
How don't you use the N?
Oh, no, there's no n here. There's no n in this equation. This is purely, I've got how big each step is, and I can see how far I've got to go. How many steps fit into that? That actually seems more like class width, right? No n involved here at all. Okay. So when you calculate this, it's called a z-score. It always tells you the number of standard deviations from the mean to the data points. Oh, shit. So a z-score, the number of standard deviations from the mean to a data point. Not only did Jeff slow down, he wrote the damn thing down. Not only have I given you this definition, I'm going to tell you every test will have a question, what does a z-score tell you? Every test, at least 10 people will get that wrong, and I don't understand it. You always want to know what's going to be on the test. Exactly. Well, there. I'm going to ask you, what does the z-score tell you? I'm going to ask you that. I might ask you, what would a z-score of 2.5 mean? What does z-score of 2.5 mean? The data point is 2.5 standard deviations away from the mean. I like it. Don't say it's 2.5 away from the mean, because then I have to be a dork and say 2.5 miles? 2.5 light years? No. So the units of measurement are standard deviations. That's like inches, centimeters, the exact same idea. How far apart are two things are in standard deviations. So what do we get for this? My data point is 9. That's what x represents as the data. My mean is 7. And my standard deviation is 2.598. What'd you guys get?
0.7698.
0.7?
770.
6.769.
7.7 basically, right?
Yeah.
You read that?
Sure did. So, the reason for z-scores, you'll see later, right now it doesn't really matter that much. Later we're going to use a chart that only goes 2 places for z-scores. That's why I kind of want to get you guys used to rounding to 2 places for z-scores. Because we're going to use a chart, it only goes 2 places. You better round to that. You guys with me? Crazy ass Jeff is going to use a chart instead of just pushing buttons. I'm sorry if that upsets you. It's too damn bad. Okay, now this last piece. So that's going to be a formula that you can put down in your formula sheet. No worries. So what about this last piece here?
You put 7 and then.
The reason I do this kind of question is there are theories about, and not just theories, but rules about what percentage of the data is within 1 standard deviation, what percentage of the data is within 2. So if I have a, stay with me now, guys. And you're all like, that's what we always try to do. If I have a normal distribution, this is really kind of nifty. If I have a normal distribution, I know a lot about what it looks like. I know it looks like a bell shape. But to be even more specific, so what kind of thing is normally distributed? Heights are normally distributed. So if everything goes according to plan, if everything's normal for you, you should be in here height-wise. If something goes wrong, something glandular or something else, then you might be at one of the extremes. And that's one reason why we call it a normal distribution. It's what's expected. Anything out here is unexpected, right? See that 7'7" tall person or that 3 foot tall person, that's unexpected. Okay. I'm going to put mu, but underneath that I'm going to put 0. What's the z-score for the mean?
0.
0, because how far away from the mean is the mean? 0. So if I put just a 1 up here, is that cool? Do you understand that? That would be the thing that is 1 standard deviation up. And then 1 standard deviation down would be -1. So z-scores can obviously be negative. The negative just means it's below the mean. So if your z-score for a test is -2, that sucks. You're 2 steps below the average. Oh, shit. So, within 1 step of the mean, if it's normally distributed, holy crap, Jeff. In 1 step of the mean, there will be 68% of the data. So, for example, men's heights have an average of I think it's 69 inches, and I think the standard deviation is 2.5. Let's make that. So it's being like 66.5 up to 71.5. So how many men are 66.5 inches tall up to 71.5 inches tall? 68%. And this is for Americans, right? Every country kind of has its own set of data. Icelandic men are like tall as shit. You guys with me a little bit? This is how you determine how wide to make airplane seats, for example. Right? Of course, Americans, size of our butts have gotten a little bigger, so they had to make it a little bigger so less of us would whine and complain, right? So if I knew the average, let's say hip width, and the standard deviation, I could set the width of the seat so that only this many people would complain. I could control the amount of complaints I could expect to get. That's an immediate use of this. Okay, so how does that relate to this question? Well, since there's a theory about what would happen with normal distributions, I want you to be able to do a concrete, well, how much is in here for just any kind of distribution? So here, what goes right in the middle, of course.
7.
Hey, there you go. Yeah, the mean goes in the middle. Now, if you go 1 step down, how big is each step?
2.598.
2.598. 1 step down will get you to where?
4.4.
4.402. And then one step up will get you to. Now the way I look at this, I don't like fish. I don't eat fish. Sorry, if you like fish, you can have all mine. Because I think I like throwing out a net. So my net goes from 4.4 to 9.6 almost. What data points did I just catch? How many?
6.
Yeah, I caught. Oh, I didn't write them down. Shoot. Silly Jeff. Yeah, I didn't catch. I didn't catch 2, but I did catch 5, 6. I caught all the way up to 9, right? So I got 1, 2, 3, 4, 5, 6. Yes. 6 out of what?
9.
9. There's 9 data points. I caught 6 data points out of 9. 6 fish out of 9, which of course is. That's pretty close to 68%. It didn't have to be. So could this maybe be close to normal? Maybe. Yes?
Alright, catch some of you with these, do you want us to actually go that detail, or would you accept this like 67%?
That's fine, 67%. Here I'm just really worried about the work you did. I almost don't care about how much you round the answer. I like it. So the mean gives me a place to start. The standard deviation gives me an idea of how to move around that. Right? If my data is like not very far apart, I don't want to move by much, or else I just miss everything. Maybe. Okay. What else do I want to say? That's it. That's it. So a couple things we got to do. I want to do the formula sheets. I'm going to go ahead and give you guys the key right now because some of you guys are like itching for this key. Anybody not even have a blank copy of the practice test yet? I don't know yet. Hold on. Anybody else need a blank copy of the practice test? Anybody else need a blank copy of the practice test?
What?
Okay.
Are you making my formula
All right, let me give you guys the answer key. And then we'll make the formula sheets. And then we'll just
How many?
start getting questions about it.
4.4 and 9.5 from here.
Oh, that's right. So like this number and this number, how many numbers are?
By the way, if you email me over the weekend with questions about homework and stuff, I'll ignore it. No, I'm joking. I'll be checking my email every now and again. And I'll be in class, as always, or as most of the time, at 8 o'clock on Monday. Right? And we're not going to start right at 9. I'm going to give some cushion room for more questions or whatever. Okay? One coming there.
I started it yesterday.
Oh, him too.
Should have started the homework. Well, I did chapter 1.
That's for you too. Make sure you get one for yourself.
I'm on 2.4 because we just learned it now, so I have to do 2.4, 5, 6,
Yeah, there should have been one for you. I guess there's so many.
The first three took me like 2 hours.
Oh, yeah.
So the last, this probably takes like 4
Oh,
hours.
there's 2 people that aren't here. I love those people.
Close. That's what he said.
He said Monday to Friday, 2 to 2:45.
He said Monday through Thursday.
That was already
He just called us wrong.
Yeah. But just reference what I said earlier today. I got to be a hard ass about it because that's how much I think you need to do to get a full understanding.
Yeah.
You got to adjust it to fit into your life and get ready for the test.
Right.
So, those are always going to be at odds, but you just do what you got to do for yourself.
It's just practice.
Yeah.
Test. For Monday.
See how his these values are the mean. So right here, see, you got these values.
Now guys, definitely hear me on this. If you put anything on your formula sheet that I don't say you can, you could lose points for that. And those points can't be gotten back. That's just not fair. You can't put examples. You can't put your own little language down there. I've had people put little symbols and they're like, oh, that's just, I don't know what that is. Be quiet. Figured out your little language. Stop it. Right? You can only put formulas. Only words that I say specifically you could use on there. Right? All of chapter 1 will not be represented on your formula sheet. It's a bunch of definitions. So no formulas from chapter 1. What do we got from chapter 2? Yes.
Before you start, can you get a note card or?
Oh, I don't care. As long as you don't make anybody else, as long as you don't mess with anybody else, you can put on this giant piece of paper. I don't care. I always joke that, those stupid little note card things, and they're like, you can put everything you want to, and you're all like, ah. And I'm thinking, when I get older, maybe I'll be on a grain of rice. You can write anything you want to, and you're all like, oh, let me see. I think it's just so stupid. You can use however big a piece of paper, as long as it doesn't mess with anybody else. You can bring a scroll in, whatever. As long as it only has the formulas on it, you're going to have to turn it in with your test. Okay. There's not going to be a bunch of formulas for this test. You might not even want to write these down, but you can put down, obviously that. This is the same stupid formula, right? Is that cool? Oh, I'm not going to let you put like the class width formula down. You got to know how to do class width for histograms. Right, so you're not allowed to put that down. Yes? No, hell no. You can't label this as mean. You can't put population sample. Those are words that I haven't said you can put down. What's up?
This one makes the first one it's mean and the second one it's mean.
No. They're both means. This is population mean.
You said you always want at least 5 classes, right?
At least what?
5 classes? Like when you
Yes.
make your Instagram?
It's how minus
Yes.
over class, right?
At least 5. Yes.
Class size.
Yes. That's the only way I can make sure you didn't do something you weren't supposed to. In fact, any sheet of paper you have on your desk during the test will be turned in. Cool? All right. And then we do, let's see, median, there's no real formula. I mean, if you want to, you can put that one little thing down. I would highly recommend not even doing it that first way I showed you and just doing the P50 idea.
Yeah.
But if you want to, don't just blindly put this down. But if you want to, you could put this. This means the depth to the median. So, you guys even have forgotten it by now. Anybody remember n plus 1 over 2?
Yeah.
Okay. This is what I mean. Don't put that down if you don't know what I'm talking about. It's like don't turn your blinker on if you're going to forget to turn the damn thing on. Alright, so don't put that down if you don't know what it is. That's crazy. Because then on the test you'll be like, oh shit, I didn't use that. Okay. How else can you find the median? It's known as P50. So then you just say 50% and blah, 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 blah. They do the same thing. Because what's cutting something in half? It's taking 50% of it. Oh, they're sort of the same mathematically. Shit. Okay. So again, this is how to find the median. And again, if you don't use this, don't put it down. Right? Don't be nice to yourself. Don't go past me, you suck. No, don't do that to yourself. All right. So me, I would say don't even write that down. Unless you use it, write it down. Let me think. Blah, blah, blah. Mid-range. You can put mid-range down. And that's the one word you can use because there's no symbol for it. I mean, range you should know. I'm not going to let you write that down. What else am I missing? Mode, this is an idea. Yeah, and then I think it's just standard deviation, I think, and then z-score. And that's about it. So we have right, that's the one we just talked about earlier. That's the standard. Is that standard deviation? What is that?
Variance.
That's variance for a population. So you can write this, or if you want to, you can write it with a big ass square root over the whole thing. Do you understand? This one just means you have to still take a square root. This one is just looks a little bit worse on your paper, so it's up to you which one. You could put both if it's not going to freak you out. I just always hate when you guys do something that's supposed to help you and it ends up hurting you. So you got to know yourself a little bit. Now right next to this I would put right, that's for the sample. So variance, population sample, standard deviation, population sample. I like it. It might keep. Okay. So anything now? That's all I can remember. Anybody have a suggestion for a formula? Oh yeah, z-score. Thank you. Now I showed you this one, but it should kind of make sense. How did I write it on there? I said x bar. Isn't that the way I had it on there? But that's for a sample. I'm going to say this, and you're not going to believe me later semester, and I don't care. Z-score formula never changes. It's always the data value I'm interested in minus the middle divided by the spread. It's always that. This is for a sample, though, right? What would it look like for a population? So maybe you want to do it like this. What does it look like for a population?
X minus the mu
Mu.
over the little,
Fat R.
yeah, that.
Sigma. So that's like all my population stuff, and over here I can put my sample stuff. You can organize it. You're not allowed to put words or examples or anything, but you can organize your formula sheet intelligently. I like it. And please, you got to understand, when you turn your formula sheet in, if it's torn, if there's stuff crossed out, I don't know when that happened. No, better be clean, no other marks, except formulas on there, nothing questionable, or else I have to assume the worst. For the honest students out there, I know that seems like too much. For the dishonest students out there, I got you. Stop it. Okay, now I'll open it up. There's a little bit of time left. Anything else you think should go on the formula sheet? Which one? The only thing? I'm asking you right now. Is there anything else you think you should be able to put on here?
Class with?
No.
No.
I said earlier in class with you got to know.
It's just measured from the it's the median.
No.
It's a median of a
Sorry.
population.
So again, guys, remember,
That's the median of a sample.
somebody asked me earlier a question. I'm not going to label the tops of the tables for standard deviation. I'm not. I'm going to give you a bunch of empty boxes so you can fill them in. But how do you know what to put up there? When you have a formula with a sum in it, you cover it and you go, oh, I need a bunch of those. Right? Then you make a bunch of those, add them up. Okay. That's how to break these formulas down.
But these are the same thing.
So hopefully.
So you either take one or the other.
Yes.
So like if this confuses you, then just do this one. And then just make sure it's covered up. Yeah.
Well, how many data points did we catch in here?
And this one is the same.
From this to this, we caught 5, 6, 6, 7, 8, 2, 9.
That's like the Z,
That's 6 data points.
Z-score.
How many data points did we catch in here? We caught 6 of them out of 9 total. No. So anybody that wants to actually stay for a bit and ask questions, you can. If you want to leave, you can. That's fine. You didn't have to come, to be honest. It's college. Ooh. I'm with you. See, this is not the like full sigma notation, but yeah, this is beautiful. That's what I'm more used to too, but this is just like basic sigma. No indices.
Oh, as long as you relate it to the physical reality of the problem. Okay, no order to it, just saying that. So, beautiful.
So that's the way I did it in my homework. And I was like,
How, did you do the Calc 2 or something?
I have done Calc 1.
Calc 1. So Riemann sums, Calc 2, when you get to chapter 11, I think it's 11, I can't remember now, 7, 8, maybe it's 8. The summation chapter. Okay. You'll be,
I know that we have like half the
the series and
half the
the
semester will be series.
people hate that. I always love that, but oh, I'm not gonna check it right now. Sorry, man. Oh well, that's all right. Yeah, but where are you at now? Huh? Oh, horrible. It's pretty good, but off and on.
How's next year?
It's not going to be the exact same. It's gonna have to be sort of close because a lot of this is so basic. There's no other real way to do it. So, I'm going to ask questions about find the mean mode, make a histogram. I'm going to ask, I don't know about true false. I can ask any kind of conceptual questions, right? It's going to be very similar to this, yeah.
How do you find the high 19?
Yes, cool. I like it.
So for this one, it's nominal then, right? Because the data's mashed potatoes, so...
Well, the data would be like mashed potatoes or french fries or whatever the options were.
Right. So I write nominal because...
Because,
and then explain it, right?
it's just
because,
easy.
yeah, and make... Yeah, okay.
I like it.
Go ahead. No, you're good.
Box line? Yes. Yeah, I think the 1G is an example of that. Yeah. So I don't need all this.